Hello everyone, welcome back. In this video we're going to solve 3.13, third type of calculation with density. Now this example, we have the element. We want to calculate the crystal structure. So by having the elements, what do we know? We know the radius, we know the density, and we know the atomic weight, which is not given here. We will find it on internet. I think it's not in the table as well. We don't have rhodium here. Yes, we don't have rhodium within the table, so we're going to bring it from internet. So we want to calculate what dense, determine whether it has an FCC or BCC crystal structure. Now from density we can calculate crystal structure, but it's a bit tedious calculation. I mean, you have to go through a lot of process in order to find the right crystal structure. Now here I know it will be between FCC or BCC, but if I don't know what I'm looking for, I have to run all of the possibilities for the crystal structure to know which one will be the crystal structure for that element. So that's why it's not preferable, but it can be used to find the crystal structure. Especially with the computer-based calculations, you can do this very easily. Now we're going to show it to you how we will be able to find this crystal structure. There are 3 to 4 ways to find it. I intend to explain 3 ways. The 4th way has some memorization of a value that also can be explained but not in detail. For those who are interested, can also go for the fourth way. So let's begin. We have the radius, we have the density, and we're going to calculate is it FCC or BCC. So we have the radius, we have the density. Let's bring the atomic weight as well. Let's say for rhodium, so again 102.9 gram per mole, 102.9 gram per mole. We're going to write this one down, 102.91, let's say 102 point, or let's take it full as its number, which is 0.055. This is gram per mole. So we have the atomic weight, we have density, we have radius. We want to calculate crystal structure. Now how can we calculate crystal structure from this equation? We said the crystal structure will decide what? N and volume of the cube. Now there is no way to tell me it's FCC or BCC directly, yes? But how can we do it? So we have 3, I'm going to explain 3 methods. Method 1, 2, 3, to see how we're dealing with this process. So method 1. In method 1, we'll assume rhodium is one of the crystal structure and we'll find density. Now, let me tell you something. If we have, say, rhodium, we have it here. If it is BCC, I can calculate this density, yes? If I know the crystal structure, I can calculate density. What if it is FCC? I still can calculate the density, yes? Now one of those 2 density shall be equal to 12.41. This is one way of finding the crystal structure. We know that it will be BCC or FCC. So I'm gonna find two radius based on what? Based in if rhodium is BCC, I'm gonna find the density. The second time, I'll find the density if rhodium is FCC. One of those two densities will be equal to 12.41, and I know that time the rhodium's crystal structure. Well, let's say if BCC, then density is equal to, in BCCN we have two atoms in BCC, N will be 2, atomic weight is the same, 102.9055, this is the atomic weight. Then in order to calculate the volume of BCC, we know that it's A cube, yes, volume VC in any time VC is equal to A cube, and A we know that in BCC A is equal to, so I can write it like this, 4 over root 3 R, we already know R, which is 0.1345 1345. Remember, this is nanometer. I'll multiply it by 10 to the power minus 7 to be centimeter. Then I'll cube all of it. This is the volume, isn't it? What I did, I directly A cube. This is what? 4 over root 3 R, which is for BCC. We know that A is equal to, A in BCC, we know it's equal to 4 over root 3 R. So I'll cube this one, and I change R, which is nanometer, to centimeter, So multiply this by Avogadro number as well, which is 6.022 10 to the power 23. Now, a simple calculation, everything you have it there, we'll calculate the density to see how much it will come. 102.9055 divided by, it's confusing, 4 divided root 3 times 0.1345. I haven't calculated, so we calculate it right now to see. This is 2 power 3 multiplied by 6.022 10 to the power 23. This is 23 here, it's not written nicely. 10 to the power 23, and that's going to give me 11.4 gram per centimeter cube. Now it's not like 12, yes, it didn't come to 12.41, so we'll check for what? If FCC, let's see in FCC does it come to be exactly that one, so we're going to calculate the same thing this time for FCC. Now if rhodium is FCC, there will be 4 atoms, still we have 102. This is the atomic weight. At the bottom here is going to change. Why? Because in FCC we know that A is equal to 2 root 2 R. So we're going to write it here. And the R, it's 0.1345. Again, I'll change it to centimeter, 10 to the power minus 7. Then I'll cube it. This will be A cube. And then multiply by Avogadro number. Now, this will give me another density. So, if I calculate this one, this will be 2 root 2. That's going to give us 12.41 gram per centimeter cube. Now, if you check with the things that it's the density was given to us is 12.41, so we know which one is it. It's FCC. So you said that rhodium has an FCC crystal structure. This is the first method that we do. We will find density if rhodium is BCC. If it is FCC, one of the two densities will be equal to the given density, which is given in the question, or the measured density which is given in the question. So 12.41, yes, we calculated here 11.4, so we know it's not BCC. We calculate for FCC, it came out 12.41, so now we know, yes, the crystal structure of rhodium is FCC. Well, we're going to explain two more methods to see which one you prefer. Doesn't matter which one, it's easier for you. You can use it to calculate the crystal structure. Thanks for listening.